Friends, we'll continue with our discussion of fuzzy sets of the previous lecture. In order to put the things in proper context, I just briefly recall the essence of previous lecture. I told that we, the living entities, are engaged in perceiving problems and solving problems. Later on we found computer as a tool. The role of the human beings and computers in this joint venture of solving problems is something like this. The human beings perceive problems and prepare a plan for the solution. I underline the word plan. On the other hand, the machines are very good at executing solutions. Therefore, the human beings take help of the computers for executing the plan prepared by the human beings. I also told that the most important tool in computer science for solving problems is algorithms. I further mentioned that the algorithmic method of solving problems is very limited in the sense that it cannot solve even a small fraction of the problems which we may encounter. Then what is the alternative for solving problems different from algorithmic methods? Then I told one of the directions is that of solving problems by exploiting the knowledge of the domain under consideration. Then I also mentioned that the knowledge, because it is the characteristic of human beings, and human beings are very good in imprecise use of words than precision. So knowledge is most of the time expressed in terms of imprecise concepts like tall, hot, sweet, beautiful, etc. So the human beings think of the solution, plan of the solution in terms of imprecise words. But I again mentioned that the computers are good only with precise entities like numbers, sets, etc. Then what is the way out? On one hand, the human beings are very good at imprecisions, understanding things expressed in imprecise terms. The computers are very good in executing the plans of solutions in terms of precise concepts of numbers and all that. Then we told that various mechanisms are there of converting this imprecision or expressing these imprecise concepts in terms of precise numbers. And one of the mechanisms is fuzzy sets. And then I discussed that how an imprecise concept of tallness can be expressed in terms of imprecise concept of numbers and sets. For this purpose, we may look at the slide once again. We said that by Indian standards, a person of height less than 5 feet may be taken as not at all tall, and a person of height 6 feet or more may be taken as definitely tall. Now we express these in terms of numbers in the interval 0 to 1. And for that purpose, if we associate a value 1 to definitely tall and a value 0 to not at all tall, it is compatible with our intuitions. It serves the purpose. But we use other ranges also, which are given on the next slide, that we use other words, a little bit tall, slightly tall, reasonably tall. Now, we know already the gradation between these phrases. Not at all tall, little bit tall, slightly tall, reasonably tall, and definitely tall. We know the increasing order with this. And so with this gradation, please, the linguistic variables which are imprecise. You may not look at the slide, please. Have been converted to the precise numbers. And this is a mechanism which is to be followed in expressing all imprecise words, hot, cold, sweet, beautiful, etc. So once we know the mechanism for converting imprecise concepts of the everyday language or natural language to the language of mathematics, next, how the computer should operate in order to solve problems. So friends, in the rest of the lectures, it will be mostly mathematical treatment of fuzzy sets. So, but first of all, as we know in the case of crisp sets or the normal sets, there is a notation. The curly brackets are there, and within that you write the elements separated by commas. For example, you have the set of rivers flowing through India, then you may write the first curly bracket, then you will write, say, Ganga, separate, comma, Yamuna, comma, Godavari, comma, and like that. So what will be the notation for the fuzzy sets? We have definitely associated degrees with various heights in the range of 0 to 1. And because we have to operate in order to solve problems, so what will be the notation for a fuzzy set? So for the notation, please look at the next slide. For this purpose, we take an example of 5 persons. 5 persons are Mohan, Sohan, Johan, Abdul, Abraham. Their respective heights are 5 feet 2 inches, 6 feet 4 inches, 5 feet 9 inches, 4 feet 8 inches, 5 feet 6 inches. So friends, as we have already agreed to associate some numbers with these heights, and these heights are associated with persons, so we will be able to associate some numbers in the range of 0 to 1 with the persons now. Now what will be the advantage? First of all, you see the advantage of this fuzzy notation is that had we talked only in terms of crisp sets, and according to our definition, only Sohan, who has 6 feet 4 inches height, is the only tall person. So if we talk in terms of our conventional sets, then we'll say the set of tall persons is equal to Sohan. However, if we use the fuzzy notation, as you'll see from the next slide, you can see now everybody appears in the set, because Mohan has height 5 feet 2 inches, and we have said that Mohan is little bit tall, and little bit has been associated a degree of 0.2. So Mohan is now associated degree 0.2, and it will be written Mohan slash 0.2. Sohan, who is 6 feet 4 inches, and according to our definition, a person of height more than 6 feet is definitely tall, with which and with definitely tall we have associated a value 1. Therefore now Sohan slash 1 indicates that Sohan is definitely tall. Johan, who is say 5 feet 7 inches, and with that height we have associated 0.7. And Abdul, who is 4 feet 8 inches. And according to our definition, any person who is less than 5 feet is not at all tall, and with not at all tall we have associated the number 0. And similarly with Abraham we have associated 0.4. Now main point which we should pay our attention to is that now the concept of tall has been expressed in terms of a set, because the curly brackets are there, the commas are there. Only difference is that now the elements are composed of 2 parts. Please look at the slide. The slide says Mohan slash 0.2. Now Mohan slash 0.2 is one element of the set. Sohan slash 1 is one element of the set. Johan slash 0.7 is one element of the set. And in this way, all the human beings which are under consideration appear there with their respective degrees of height. And once this is done, it becomes a mathematical entity. Now this is also a set, which is a crisp set, which is a conventional set which we have studied so far. Only the elements are a bit different type. Mohan/0.2 is one single element. And you will see the advantage of this in solving problems. So first of all, I draw your attention to the fact that the fuzzy concept, the imprecise concept of tall, from which you did not get a unique idea, has been associated a set which has definite meaning. This is a first big achievement. Actually, Zadeh, a great philosopher, mathematician, he generated the idea of fuzzy in 1968. And earlier the fuzzy was not a very popular concept even among academicians. Later on, Japanese actually used the fuzzy logic in their machines and all that, and from there the fuzzy theory, etc., became very popular. And you'll see the use of this nowadays. Your machines have fuzzy logic operating machines and all. So how it operates? We in an academic discipline are not to be dazzled by the technology, but we have to find out the reasons how it functions the way it functions. And that is the purpose of study of any academic discipline. So we'll see how the machines or the computers are able to function with the associated definite concepts of sets in which the elements have two components, namely the name of the person and in this particular case the degree of tallness. So now the rest will, in the rest of the lectures we will concentrate on whatever operations are there in crisp sets, which you know, intersection is there, union is there, complementation is there, etc., etc. How those operations are carried out on these sets in which the elements are not just ordinary elements, but they contain two components. One is the name of the person and the second component is the associated degree. How we get the associated degree through various mathematical operations, this is what we are going to discuss in the rest of the lecture. Please look at the next slide. Well, first of all, what is the complement of? First of all, we have to think at intuitional level, because that is very important. If we are not able to make the correspondence between the intuitive notions and the formal notions of mathematics, it is not possible to use the fuzzy logic. So here, you know what is the complement of tall? The complement of tall is short. And more a person tall, less the same person is short. So vice versa. So what our intuition says? Our intuition says if the degree of tallness is more, then the degree of shortness should be reverse of that. I hope that is very clear. So by using this reasoning, intuitive reasoning, we get the definition of short, that is whosoever has degree say point x, you get the degree of shortness as 1 minus point x. So here, while looking at the slide, we get that Mohan, who has tall degree 0.2, should have degree of shortness as 0.8. Someone who is definitely tall should not be at all short. And the degree of shortness of Sohan, who is 6 feet 4 inches, should be 0. And similarly, you can find out the degrees of the other elements by subtracting from 1 the degree of tallness in order to get the degree of shortness. And what is this? This is your complementation in mathematics. Yeah, that is, you know that the set of tall union the set of short is equal to the set of all human beings. And therefore, what is set of short? It is complement of set of tall in the universal set. So this is, but first of all, you must understand it at the intuitional level. Once you are able to make the correspondence in your mind, then it should not be a problem for doing the rest of the things. So friends, equality of sets, naturally. First of all, what are the concepts in crisp sets or your normal sets? Equality of set is the very first concept whenever you discuss your conventional sets. The next, yes please. Hello?
Hello?
Yes please.
Hello?
Hello? Please carry on.
Hello?
Yes please. Please carry on.
TCTI Delhi.
Yes, please go on. Hello.
कि कुछ बच्चे पूछ रहे. हेलो.
Please go ahead. I am listening.
सर पहले तो सिलेबस आप बता दीजिए सर पहले.
Hello.
हेलो.
Yes, please. I think you are talking about the syllabus. Well, we have
Yes sir.
we have uploaded the block 3 and block 4 on the net, number 1. Number 2,
Next sir.
Hello.
You put the slides on IGNOU website.
Well, IGNOU's site.
Hello.
And what you can do, please, is you mail me on lalmanohar03@yahoo.com. I repeat, lalmanohar03@yahoo.com. The second email address is lalmanohar@hotmail.com. In the Yahoo address there is 03. And you mail whatever is your question, it will be immediately responded. For the time being, I can say about the syllabus that the already 2 blocks have been uploaded on the net, and the site can be known from the email and otherwise also by making a call to the department. And the third, that is second block, the third block you can say, second, third and fourth will be available by Monday evening on the net. And the summary of block first will be also available. And within a week, the whole material consisting of summary of block 1, block 2, block 3, block 4, within a week it will be dispatched to the students. So from the material itself, you can know the syllabus, and otherwise also it should be available in the program guide. I hope you are satisfied. So we continue with our lecture on the fuzzy sets. I told you that once the imprecise concepts of everyday language are expressed in terms of sets, where now the sets have elements of the form, the name / the associated degree. But anyway, these are your conventional sets. Fuzzy sets is just a nomenclature in order to show the degree, but otherwise their behavior should be just like crisp sets. Now in the case of crisp sets, we have a number of relations and operations. I recall the very first relation between sets is that of equality of 2 sets. Hello? Hello?
Hello.
Yes, please.
Hello.
Yes, please.
Sir, I would like to know about the intersection in crisp sets.
I'll come to that. Please. Had you waited?
One more thing.
Yes, please. Please carry on.
I would like to know about the list programming, sir.
List programming.
That we are in syllabus.
Yeah. Please, what we can do, 2 things. Number 1.
Thank you, sir.
Do you have any more question, please? So, the girl wants about 2 things. Number 1, what is the intersection of 2 sets? And list programming. So far as list programming is concerned, my lecture is in the late May, when I'll be speaking on list programming in detail. So please wait for that. And in the meantime, you will have the material also available in all forms, electronic as well as printed form. So far as intersection of 2 sets, please wait for a minute. I am going to discuss that. So friends, I was telling you, the fuzzy concepts are converted to crisp sets, where each element now is the name associated degree. Now in the case of crisp sets, what are the various relations and operations we discuss in general? First relation which we discuss in the case of crisp set is equality of 2 sets. Then we discuss the various operations like complementation, intersection, union and all that. So one by one we take first of all the concept for crisp set, then the corresponding concept for fuzzy sets and so on. So first of all we know the equality of sets by definition, which is taught in 7th or 8th standard also, that every element of A is an element of B and every element of B is an element of A, then the two sets A and B are said to be equal. You may have a look at the slide also. So in this particular case, you can see every element of A is an element of B and vice versa, though there are repetitions and this rearrangement also. But still A and B are said to be equal. However, here there may be some difference, that is element 1 is repeated twice, and in some cases we don't take it as set, but just for the sake of explanation I have said that the elements may be repeated, still the size of the set doesn't become large. Now what will be the, similarly you know the subset also. In this particular case you can see that B is a subset of A, however C is not a subset of A because the element 8 occurs in C which is not appearing in A. So intuitively we understand what is meant by equality of sets and subset. Now similarly we know the meaning of what is meant by belongs to and all that. Now we'll come to the corresponding definitions. And we have already considered the example of Mohan, Sohan, Johan, Abdul, Ibrahim. This is called the universal set for fuzzy sets. And various degrees are associated with these persons in this particular set, which is a crisp set, in order to express a fuzzy concept. So next slide. Now we explain the concept of equality of fuzzy sets. I think by this time you must have guessed when two fuzzy sets should be equal. That is, if the same name appears with the same associated degrees. So friends, please look at the slide once again. The slide says that A is the set in which Mohan has degree 0.2, Sohan 1, Johan 7, etc. Similarly in the B set, Ibrahim has degree 0.4, Mohan has degree 0.2, Sohan has degree 1 and Johan has 0.7. So the orders are different, but you can see that same persons with associated degrees are same, and therefore two sets A and B are equal, and I think it corresponds to our intuition also. So the concept of equality which prevails in crisp set or conventional set is extended to the equality of fuzzy sets. Please look at. Now you can see, in the case of set C, same elements appear, but the degree of Abraham is 0.2 in C and it is 0.4 in A, therefore A is not equal to C. I hope now it must be clear, same elements, and not only the same elements but associated degrees also must be same if two fuzzy sets are said to be equal. Next we take subset. Again you know that set of all tall persons should be a superset intuitively of the set of very tall persons, because the set of very tall persons, every very tall person should be a tall person also. That is, the number of very tall persons should be less and every very tall person should be a tall person also. And this guides us the definition of subset of a fuzzy set. I hope you must have guessed by this time, if the same persons appear, however the degrees are less, then the set with lesser degrees will be called a subset of the set with more degrees. This guides, and how it is expressed is available on the next slide. Please look at this slide. So we can formally describe it as, if A and B are fuzzy sets with universal set X, universal set is the set from which all the elements like Mohan, Sohan, Johan, etc. have come. And if we have A is equal to Xi by Vi and B is Xi by Wi, that is the degree of element Xi is Wi, then we will say that B is a subset of A if the associated degrees of elements in B is less than equal to the corresponding associated degree of the elements in A. In this example, you can see A and B are there. The degrees of Mohan are equal in the two sets. However, the degree of Sohan in B is less. Again, degree of Johan is same, Abdul is same, Abraham, again the degree of Abraham in B is less than, and therefore we can say B is a subset of A. Here you can take B as the set of very tall persons, A as the set of tall persons. And you know, every very tall person is a tall person, therefore the set of very tall persons should be a subset of the tall persons. And this clarifies the notation also, the justification for the notation also. Yes, please. Yes, please, come ahead.
Yes, please. Hello.
Yes, please.
Sir. Hello.
Yes, please.
Hello.
Yes, please.
Sir, what is mean of fuzzy logic?
Yeah. Please carry on.
And any reference book of AI?
Well, please, I tell you, I'll be giving you some references at the end. Please. Number one. Number two, again I suggest that you look for the material on the web. And the third alternative is to make an email to me. First of all, the material on the web also consists all the references. And otherwise, you can mail me also. And I'll be giving at the end also some references. Before 5 minutes of the close of the talk, we'll be giving references also.
Hello,
Please.
sir.
So, friends, hello.
What is fuzzy logic?
Yes, please. Please carry
What
on.
is fuzzy logic?
Yes, please. Your question is not clear. Can you repeat it?
Sir, what is fuzzy logic? Please describe
Please,
that.
I am telling you once again, the whole of the 2 lectures are just defining what is fuzzy logic, why we study fuzzy logic. Briefly, I tell you once again that fuzzy logic deals with the imprecision in the language, like the words tall, small, sweet, beautiful. These are not very precise words which are used.
And what is that? Please give me example. Any example, sir?
Well, if you listen and if you are really careful, I have given at least 3 or 4 examples of fuzzy. I advise you to listen properly before asking question, because it is undue
Thank you,
interference.
sir.
Please listen. We have already considered a number of examples of fuzzy set. Just on the slide at present is 2 examples of fuzzy set. A is a fuzzy set, B is a fuzzy set. What is the difference between the normal set and a fuzzy set is? For example, if you look at A, it is not a set of Mohan, Sohan, Johan, Abdul and Abraham. It is not. It is a set of the names associated with degrees. Mohan is associated degree 0.2. Sohan is associated degree 1, and so on. And once the elements are expressed in this form, then it is representing a fuzzy set. It is not a normal or crisp set. I now hope that you understand how a fuzzy set is represented. And I have told you that this is being done. Why we are taking the problem of doing all this business is because we want to express the imprecise concepts like tall in terms of mathematical entities like sets. And once these are converted in terms of mathematical entities, it is easier for the computer to operate. And now we are telling how the computer will be, what operations it will be applying in order to solve problems. And the very first relation I am describing is that when 2 sets which are fuzzy sets are equal to each other, then I expressed when a set is said to be a subset of another fuzzy set. This I have expressed. If we go ahead, then we'll find out how the intersection of 2 fuzzy sets is found, how the union of 2 fuzzy sets are found, how the other operations on crisp sets are simulated for fuzzy sets. That is what is the rest of the discussion meant for. Please. So please look at the next slide. We have already seen B is a fuzzy set of A, because now we have said a fuzzy set B is a subset of a fuzzy set A if the same names appear, however the degree in the subset should be less than equal to the degree in the main set. Then these B is called a subset, fuzzy subset of A. Now we look some other example. We know that corresponding to belongs in Chris set, the word or the phrase belongs to has been replaced now by degree of membership. And one more thing we may be noting, that every Chris set may be represented as a fuzzy set but not conversely. You can see from the next example. Please look at this. Now A is the set of those elements or human beings out of the 5 persons which we are considering who are at least graduates. So the Chris set will be Mohan, Johan, Abdul, because they are at least graduates. We in the previous slide, we have said please, we say Mohan is a PhD, therefore the degree of education in this particular case, because Mohan, Johan and Abdul are graduates and the set of sets consists of Mohan, Johan, Abdul, but rest of the people are not graduates, so they are eliminated in the conventional method of sets. So the conventional set can be expressed as a fuzzy set in the sense that whatever element is there in the Chris set is associated degree 1, and whatever element is absent is associated degree 0. Therefore, the Chris set Mohan, Johan, Abdul has become the Chris set Mohan with degree 1, Sohan with degree 0, because Sohan is not a graduate, is not present in the set A. Johan is again having degree 1 because Johan is a graduate. Abdul is also a graduate, so the degree associated with Abdul is 1. And Abraham is associated degree 0 because Abraham is not in the set of A of graduates. So what I mean to say, every Chris set can be thought of as a fuzzy set, but every fuzzy set may not be thought of as a Chris set is clear from the next example. We here take degree of education of the people, that whosoever has a PhD degree may be called as degree of education 1. Those who are masters holders, they may be said to be educated of level or degree 0.85. Next is degree of education which we associate with a bachelor may be 0.6. Degree of education with 10 plus 2 we associate is 0.4. Degree of education which we associate with the 8th standard is 0.1. And degree of education which is associated with a person having education less than 8th. Now this is a fuzzy set. This can be, yes please.
Hello sir, good afternoon.
Good afternoon please.
From Raj. Sir, just I want to know proper structure of fuzzy set, and I'm going to confuse difference between fuzzy and Chris set.
Please, let me answer the question.
Yes.
Actually, when we say a set, your Chris set is nothing else but the set which you have studied so far. The set which you have studied in your 10 plus 2. When you say a set in that sense means either any element on the earth is in that set or not in that set. For example, we take the set of natural numbers. 1, 2, 3, etc. belong to the set of natural numbers. 0.5 is not a natural number. A pen is not a natural number. A human being is not a natural number. So your conventional sets are such that you pick up anything in the universe or from the world. You should be able to tell whether that particular element is in the set under consideration or not. As I said, a pen is not a member of the set of natural numbers. 0.5 is not a member of the set of natural numbers. So this is your conventional sets, but in order to differentiate between fuzzy and the conventional sets, we start calling your sets which you have been calling so far as sets as crisp set. That is the only thing because of which we are using the adjective crisp. I hope the difference must be clear. And I have told you in the case of fuzzy sets, all the elements of the universe occur, but with a difference, that every element is associated a degree of belonging. You can say degree of belonging now. That when you have a set of tall persons, now every tall is not equally tall. We have to differentiate between the two. So a person having a height of 6 feet 4 inches have a sort of different sense of tallness as compared to a person who has a height of 5 feet 2 inches. And that is the very purpose of study of fuzzy logic. That how do we differentiate between these same word denoting a number of concepts. And that is how we differentiate between the sets, which now we have started calling crisp sets, and the fuzzy sets, which actually carry on our intuition of differentiating between a height of 6 feet 4 inches from a height which is 5 feet 2 inches, which carry on that in terms of, but what is the difference? That your ordinary language, slightly tall, definitely tall, reasonably tall, have now been converted in terms of numbers. And that is big achievement, because numbers are easily operable. Computers are very good at operating numbers. So I hope you understand the rationale behind the study of fuzzy sets, relations, functions, etc. Okay, now let us go ahead. I was saying that every ordinary set, a crisp set, may be expressed as a fuzzy set in the sense those elements which are present in the set are associated at degree 1, and those elements which are missing from the set are associated at degree 0, and hence every crisp set or ordinary set can be thought of as a fuzzy set, but the converse is not true. For example, if you associate degree of educatedness with a PhD as 1 and with a matriculate as 0.1 or something like that, and a degree of education with a 10+2 level person as 0.4, then this set cannot be expressed as a crisp set. You can see from the slide, please look at the slide. For example, the set C, Mohan is having degree 8.5, Sohan who is just a 10+2 is having degree 0.4, so, Johan who has a bachelor's degree is associated 0.6, and so on and so forth. Now this set cannot be expressed in terms of crisp set, because the associated degrees have to be eliminated, and once the degrees are eliminated, the very rational, we cannot know who is educated and who is not educated. So with this difference, please, this set, in this particular case the associated degree and the elements are there. If you remove the degrees and keep only the elements Mohan, Sohan, Johan, Abdul, Abraham, then it is called set of sport also. Now in the case of set of, that was called universal set. In the case of set of sport, we just want to carry on our intuition of belonging or not belonging, and you know a person having degree 0 actually is nominally present over there, otherwise he should not have been present. For example, Abraham cannot be said to be educated at all because he is less than 8th class pass, and we will not like to keep Abraham in this set, but because fuzzy set compels us to associate some degree, so set of sport says that eliminate those elements which have degree 0, and therefore set of sport consists of only 4 elements, Mohan, Sohan, Johan, Abdul. What does this mean? These are the elements which have non-zero degrees. Okay, so now we'll fuzzy singleton. The concept is there. You know the singleton set is a set in which there is only one element. So here, what is meant by fuzzy singleton? If there is only one element which has non-zero degree, only one element has non-zero degree, then that is called a fuzzy singleton. Here you can see, if we call everybody below 20 years as not old, that is degree associated is 0, and a person of 25 years has a degree 0.2, then the set, this has only one element which has non-zero degree associated is Johan, therefore then the sport of old is equal to Johan, that is Johan is the only element which has an associated degree which is not 0. Now further we like to explain the concepts of intersection, union and all that in the remaining 5. I hope you must have understood. What is intersection in crisp sets? Please recall it. Intersection of two sets is the largest set contained in both the sets. Please recall, A intersection B is the largest set which is contained in B as well as in A. Now what is the corresponding of this? The correspondence of intersection of two fuzzy sets says that intersection of two fuzzy sets is the set of all elements with associated degrees which are larger of the two. And the union is in which the degrees are the minimum of the two. So hurriedly, because the time is almost completing, we can see that A union B, first of all I am recalling the definition for Chris set at the slides, and then I will be giving the corresponding. I just recall A union B is the smallest subset of X containing both A and B, containing both A and B. A intersection B is the largest subset of X contained in both A and B. So corresponding to this, we have the concepts of, please, yes, the union of two fuzzy sets is the set of all those elements in which the degree of an element be equal to the maximum of the degrees in the two sets. And please excuse me, it should be the reverse. Union of two fuzzy sets is the set of all those elements in which the minimum of the degree is there, and the intersection should contain, meaning this is a printing mistake. Union of two fuzzy sets is the set of all those elements in the degree of an element be equal to minimum of the degrees. And intersection of two sets is the set of all those elements in the degree associated with each element is the maximum of the degree. Let us clarify it through an example, please. Now these are the two sets before us. I want to tell what is C union F and C intersection F. Please, yes please. Please go ahead.
Hello sir.
Please.
I am Ravindra Kumar calling from Delhi.
Please, please.
Sir, we know that our examination starting from 1 June, starting time is less than 1 month. But elective material is not available. How prepare the examination point of view?
Would you repeat your question, please? Would you?
We know that our examination is starting from 1 June.
Yeah, I know that.
But elective material is not available.
Well, the
How
material.
prepare the examination?
Well, I have repeatedly said this, that the material of two blocks is already on the site, and the material of the another block will be put on the site by Monday evening. So this is the only answer at present, because I like to discuss the rest whatever I am doing here, and you can send your query through the email. So friends, well, this is the union and intersection, that in the C union F and C intersection F, the degrees are taken either the minimum or maximum as is shown on the slide, because the time is almost over. So one thing I'll give you some references, which please look at the references. These are the references, please. Chapter 5 of Fundamentals of New Artificial Intelligence Beyond Traditional Paradigm for Toshinori and Monikata, a first course in fuzzy logic by Tu Huang and Albert Walker. However, for your purpose, our two books, one by Peterson and the other by Elaine Reach, will be more than sufficient. So please, you need not go to these two books. These are, though are very elementary, very good, but the availability is a problem. However, our two books, which are sufficiently available in most of the regional libraries and all that study centers, and even you must be having a copy of Peterson's book, or if it is not available, it should be very easily available. So Peterson's book and your very well known this Reach's book, whatever fuzzy material is contained over there, that will be sufficient for your person. So with this, I hope the concept of fuzziness must be clear to all of you. Thank you.